So we'll talk about this and we'll go through some examples of this in class on Tuesday. But we know that solution concentration can be found through molarity, or can be thought of as a molarity. And we have the equation for molarity. Molarity is moles of solute per 1 liter of solution. This is the definition of molarity. It will never change. However, sometimes we don't know the moles of the solute, or we don't know the volume of solution. A lot of times it's more accurate to weigh out the masses of things rather than measuring out the volume. So what happens is, a lot of times in laboratories, we'll talk about the mass percent of a solution, which is another way of talking about concentration. So this is a great unit. The liter of solution, it's really hard to get very accurate numbers for volume, but it's very easy to get very accurate numbers for mass. So we're going to take this idea of concentration and we're going to move it into the mass world, and it'll help us, it'll make it easier in laboratory for us to calculate this molarity. So here we go. We can also find a type of concentration using masses. It's not going to have this definition of molarity, but it's similar to our mass percents that we've seen before. So the solution's mass percent is going to be the grams of solute. So if we're taking sodium chloride and throwing it in water, it's going to be the grams of sodium chloride divided by the total grams of solution. So we know in this case that due to the law of conservation of mass, that the total mass of the solution is going to be the mass of the solute plus the mass of the solvent. This is much easier to calculate than to find the volume of solution, because remember, volume is not additive all the time, but mass is. So this is a more accurate way of calculating concentration. We need to find the grams of solute, we need to find the total grams of solution. Then we then multiply that number by 100% and we get our solution's mass percent. So let's look at an example, a quick example, and then that'll be it for this video. So what is the mass percent of a solution that was made by adding 50.0 grams of sodium chloride with 500 grams of H2O? So first off, we need to know the grams of solute. Well, we know in this case that the sodium chloride is going to be our solute, it's dissolving, so we know the mass of the solute. We aren't given the mass of the solution. We're given the mass of the solvent, which is water. In order to find the mass of the solution, we need to add these two numbers together. We can do this because of the law of mass conservation. So we've been dealing with that law a lot. I told you that these mass laws come up regularly throughout chemistry. This is another instance where these mass laws are going to show their faces again. So the total mass of the solution is just going to be the mass of the solute, and you're going to add to that the mass of the solvent, and that gives you the total mass of the solution. This is easy to weigh out in a laboratory. So a lot of times you'll see mass percents, solutions concentrations in mass percent, rather than in molarity when you're in a stock room. We can easily calculate the solution's mass percent by taking the mass of the solute, which is the 50 grams of sodium chloride, and then dividing by the total mass of the solution, 550 total grams of solution times 100. That gives us a mass percent of 9.09% sodium chloride by mass. This is identical to what we did when we were talking about mass percents of different compounds or different elements in a compound. Same procedure, we're just applying that knowledge to a new system. We're applying it to the solution chemistry.